Welcome to This Explainer. Today, we're diving straight into the Sustainable Industry Classification System, or SICS, and we're specifically unpacking the vital sustainability metrics designed for the home builders industry. If you want to understand how the modern real estate market is adapting to climate change, resource scarcity, and community impacts, you really have to understand the metrics that track it all. Now, before we map out the business model itself, it's important to note that this framework is part of the SASB standards, which are actually now overseen by the International Sustainability Standards Board, or the ISSB. This isn't just some niche, theoretical set of guidelines. It's a globally recognized accounting standard that investors rely on every day to spot sustainability-related risks and opportunities, the kind that actually make a tangible difference to a company's cash flows and cost of capital. Okay, let's lay down our foundation. The IFHCOD code places home builders right smack in the middle of the infrastructure sector. And that categorization, it's key. It highlights their massive, very tangible impact on our physical world. Home builders don't just put up houses, right? They develop entire residential communities, they tap into local water and power grids, and they permanently alter the landscapes they build on. To really wrap our heads around these complex metrics, we're going to follow the literal blueprint of how a residential community is actually created. We'll track the builder's footprint across 4 core business phases: land acquisition, site preparation, home construction, and finally, home sales. So our roadmap for today covers those 4 phases. Phase 1, land acquisition. Phase 2, site preparation. Phase 3, home construction. And Phase 4, home sales. Let's start with Phase 1, land acquisition. It's right here at the very beginning that critical choices about climate adaptation are permanently locked in. Basically, once you buy the land, you inherit all of its environmental realities. The sheer scale of a builder's environmental footprint at this stage is quantified by one primary activity metric, and that is the number of controlled lots they have in their pipeline. This includes all the lots they own outright, plus those that are contractually available to them through options. To put that into perspective for a second, top home builders can control hundreds of thousands of lots at any given time. You just simply can't measure sustainability without knowing the sheer volume of land a developer is sitting on. This brings us to a really fascinating risk versus opportunity matrix at the acquisition stage. On the risk side of things, developers have to report exactly how many lots are located in 100-year flood zones, which are areas with a 1% chance of flooding in any given year, or regions with high baseline water stress, using tools like the World Resources Institute's Water Risk Atlas. Building in those vulnerable areas risks serious land value depreciation, higher insurance rates, and absolute permitting nightmares. But on the flip side, the huge opportunity lies in sustainable community impacts. Builders can prioritize what are called infill sites. These are vacant or underutilized lots already plugged into existing public infrastructure like roads and sewers. Or they can design compact, mixed-use developments that actively preserve natural open spaces. Moving right along to Phase 2, site preparation. Now, as developers actually break ground, the focus shifts directly to ecological impact. Instead of just clearing out undisturbed natural greenfields, the smartest developers revitalize local environments by targeting redevelopment sites. The standard tracks the number of lots and homes delivered on 2 very specific types of redevelopment areas: brownfield and grayfield sites. Brownfields are tricky. They're properties where expansion or reuse might be complicated by the potential presence of hazardous substances or pollutants. Grayfields, on the other hand, are previously developed sites where at least 50% of the surface area is covered with impervious material. Think of an abandoned, paved-over shopping mall parking lot. Reclaiming either of these sites is just a massive win for local ecosystems. But here's the catch. Breaking ground is heavily regulated. Failing to manage site prep properly leads directly to this crucial metric: the total monetary losses from environmental regulation violations. We're talking about massive fines and legal settlements that come from things like groundwater contamination, mismanaging hazardous waste, or even just improper stormwater runoff. Repeated violations don't just ding the bottom line for a quarter, they absolutely destroy a builder's brand value and community trust, which makes it incredibly difficult to ever get approval for future projects. Which brings us to Phase 3, home construction. All right, the land is prepped, but how do we protect the actual humans building these homes? Construction requires a massive amount of manual labor, and it's highly physically demanding. Workers are facing constant risks every day, from falls, heavy machinery, and extreme weather exposure. Because of this, companies are required to meticulously track their total recordable incident rate, or TIIR, as well as their fatality rate. And get this, they can't just report the stats for their corporate office stuff. The SASB standard explicitly requires them to separate and report these safety rates for both their direct employees and their contract employees. Those third-party subcontractors are the ones who often do the heaviest lifting. High incident rates lead to major project delays, skyrocketing workers' compensation costs, and intense regulatory scrutiny. It literally threatens the builder's entire social license to operate. And finally, phase 4, home sales. The house is built, the keys are ready to be handed over, and that places a massive spotlight squarely on design for resource efficiency. When occupied, residential buildings consume vast amounts of energy and water. So, the standard tracks how many homes are delivered that meet rigorous third-party multi-attribute green building standards, like LEED for homes, for instance. To actually hit these certifications, a home must excel across 5 key attributes: energy efficiency, water conservation, material and resource efficiency, indoor environmental quality, and, this is a really crucial one, owner education. By systematically educating buyers on how to properly use these eco-features, builders are creating a serious competitive advantage, driving down the homebuyer's long-term utility bills and ultimately increasing demand. And this commitment to resource efficiency? It gets incredibly specific. The standard tracks data all the way down to the granular level of the percentage of installed water fixtures certified to jurisdictional water efficiency standards. We are literally talking about tracking every single low-flow shower head, bathroom faucet, and smart irrigation controller in communities that are already facing severe water scarcity. Outfitting a new development with certified efficient fixtures is not just a nice-to-have upgrade, it's vital for alleviating stress on community water supplies and ensuring the whole development is actually viable in the long run. As we wrap up this explainer, we really have to look at the big picture. We've traced these sustainability metrics all the way from raw land acquisition to the final water-efficient fixtures inside a sold home. The data required by the IHFHB standard forces developers to confront physical, climate risks and ecological impacts completely head-on. So we're left with a pretty massive question. If extreme weather events and resource scarcity continue to escalate the way they are, how will mastering these exact sustainability metrics dictate which home builders survive, which ones thrive, and ultimately, how will it completely redefine the true financial value of real estate in our changing world? Thanks for joining me on this deep dive.